Good morning, students. Today we will start or continue the chapter 10, chapter number 10. We will continue this chapter. Today we will discuss the concepts of two exercises, that is exercise number 10.3 and 10.4. Concepts of exercise 10.3 and exercise 10.4. As we have discussed what are scalar and vector quantities and how to get the component of the vector and other properties we have discussed about vectors in exercise 10.2. Now today we will just discuss how to get the product of two vectors. Product of two vectors. Product of two vectors. As if you recall your previous classes, when we multiply the numbers, we may got positive number, may got negative number. Similarly, when we multiply two vectors, maybe we got scalar quantity or maybe we got vector quantity. Two types will be there, first scalar or other is vector. Suppose there are two vectors. First we will discuss dot product, that we say scalar product. Suppose A and B are two vectors. A and B are two vectors such that A vector dot product with B vector will be equal to magnitude of A vector, magnitude of B vector into cos of theta, where theta is the angle between A and B, where theta is angle between A vector and B vector. Here first we will discuss dot product and its properties. Now for properties, you must know properties means first, if you multiply A to B or B to A, both are, you are getting same answer. A dot B and B dot A both are same. So this law is known as commutative law. Commutative law. Second property, if you multiply here is the second property, A vector dot product lambda times of B vector is equal to lambda times of A vector into B vector, and you are getting lambda times of A dot B vector, where lambda is any scalar quantity. Scalar quantity. Maybe 2, maybe 3, minus 2, minus 3, maybe. And next one is A vector dot product with B plus C. I think you know this is a distributive property. Those who studied physics, they know about it. A vector dot B vector plus A vector dot C vector. And this is known as the distributive property. Distributive law or distributive property. A vector dot B vector equal to 0. What this implies? This implies either A equal to 0, B equal to 0, or A vector is perpendicular to B vector. Okay. Next one property, if vector A is given to you, that is suppose A1I vector plus A2J plus A3K vector, and B is given, suppose B1I plus B2J plus B3K. Then if you want to calculate A dot product with B, it means their scalar parts are multiplied. A1 B1 plus A2 B2 plus A3 B3. This is the product of A and B. This is because of just what? This is because of, if you want to know, when you multiply by these I into I, you must know that I unit vector dot product with I, that is equal to J equal to K dot K. All these are equal to 1. And if two different unit vectors are multiplied, I dot J dot K and K dot I, these are equal to 0. You know, I, J, K are the unit vectors along x-axis, y-axis and z-axis. Now next one is the topic for dot product, that is the projection of a vector on another vector. Suppose projection of A vector on B you want to calculate, that will be A dot product with B and magnitude of B in denominator. If that is projection of B on A, in case that is same A dot B product on in the numerator, but in the denominator it will be A vector magnitude. If you want to calculate projection vector of A on B, if you want projection vector, not projection vector we want to calculate, vector of A on B, then that will be equal to mod of A dot B product upon magnitude of B square into B vector, dot product with B vector. If you want projection of B vector on A vector, projection vector will be, that is dot product of A and B, magnitude of A vector square into A vector. This is a projection vector. This is only projection of A. There's a difference. Now for the angle, if you want to know about the angle, if theta is the angle between A and B, if theta is the angle between A and B, where A is equal to A1I plus A2J plus A3K and B vector is equal to B1I, B2J plus B3K, then cos of theta can be calculated by using these two, dot product of A and B divided by magnitude of A vector and magnitude of B vector. Or you can say this is A1 B1 plus A2 B2 A3, as I told you. Product means this one, magnitude means under the root A1 square plus A2 square plus A3 square into magnitude of B means B1 square plus B2 square plus B3 square. This is the way to calculate the angle. Now, if A vector is perpendicular to B vector, what this implies? A dot B will be equal to 0. I have told previous. Or you can say that A dot B equal to 0 means from here what you will get? You will get A1 B1 A2 B2 A3 B3. This is equal to, oh no, A1, A2, A3, B1, B2, B3, and then A1, A2, B1, B2. Here I have just that is A1, B1, A2, B2, A2, B2, A2, B2, A3. Yes, here A3 will be equal to 0. Now these are the properties of the dot product. Now let's discuss along with this the cross product will be what? Cross product means when you are multiplying two vectors, you are getting vector quantity, not a scalar quantity. It means we will discuss cross product now. Cross product means vector quantity is the result. So if in the case of cross product or vector product, two vectors, suppose A and B are given to you, vector A and vector B are given to you, then cross product A cross product with B, that is equal to magnitude of A vector, magnitude of B vector into sine theta. Here when vector your vector result you are getting, it means direction should be there, and n cap vector, where theta is the angle between A and B, and n cap is a unit vector perpendicular to the plane of A and B, and positive for right-handed rotation from A to B. You must remember it, what I have told you, where theta is the angle between A and B, and n cap is a unit vector perpendicular to both vectors A and B, and positive for the right-handed rotation. Rotation is from A to B. Now, if you want here, this implies here, if you want sine theta from here, you will get A magnitude of this, magnitude of A vector, magnitude of B vector. You can calculate the sine theta. Now properties for cross product. First property is A cross B is not equal to B cross A. That is equal to minus of B cross A. This is very important. Second one, if two same vectors are crossed, multiplication take place in two cross same vectors, then that is equal to always 0. Or you can say here is the unit vector maybe here. You can write like this also. That will be equal to 0 vector. Okay. Now next one, property which you must know, that is the property I cap cross j cap will be equal to k cap, and j cap cross k cap is equal to I cap, and k cap cross I cap will be equal to j cap. If these are interchanged, then I have told you I cross j is equal to minus of j cross I, or you can say j cross k is equal to minus of k cross j, and last one, that is k cross I, that is equal to minus I cross k vector. Next one, if A cross B, it means cross product is 0. What this implies, you must know either A0 vector B0 or A vector is parallel to B vector. Maybe any of these conditions will be there. Now how to calculate A cross B? If A vector is equal to A1I plus A2J plus A3K, and B vector is equal to B1I plus B2J plus B3K, then you can calculate A cross B vector, that is equal to, I hope you know the determinant, how to solve the determinant, ijk in a first row, and the scalar quantities of the first vector a1, a2, a3, and second vector b1, b2, b3. Now you can solve by using the determinant. You can solve it. Now next property for this is, if you want area of parallelogram, then again cross product is used. Area of parallelogram whose sides are represented by A and B, then cross product magnitude is known as the, if A and B are sides of parallelogram. Okay. Now how to calculate the unit vector perpendicular to both A and B? You must know unit vector perpendicular to A and B both, that is A cross B and divided by its magnitude. Suppose you want area of parallelogram if A and B are diagonals of figure, then how to get the area? That will be equal to half of magnitude of cross product A cross B, where in the first, these are the sides, here I have told you diagonals, the formula is different. So you have to remember. Now area of triangle whose two sides are represented by A and B, area of triangle whose two sides are A and B, then that is again written as A cross product with B upon 2 or half of the magnitude of A cross B. These are the formulae which you have to learn for dot product and cross product, or you can scalar product and vector product. Now further we will do few questions of exercise 10.3 and 10.4. Let's do few questions of exercise 10.3. Exercise 10.3. Let's do questions. Open your NCERT book. Let's do the question. Let's do the questions. Suppose question is, I will do question which are so important for you to do. Let's do question number 9 first. Question number 9. 2 or 3 questions I will just told you, and you will try other questions your own. Find, here you have to find magnitude of vector x if for a unit vector A, x minus A dot product with x plus A equal to 12. Now you know you can multiply them, x dot x minus A dot x plus x dot A minus A dot A, that is equal to 12. Now what are the values? This can be written as mod of x square minus x into a or x into a or a into x, both are same. You can cancel them. This is into sign. This is mod of a square is equal to 12. Or you can say the value is given here. This is a unit vector 1 and 12. Mod of x square is equal to 13, or mod of x will be equal to root 13. This is the answer of question number 9. Now here is a question. Let's do the question number. All questions you have to try first, then we'll discuss. I think question number 11. Question number 11 is show that mod of a b plus b is perpendicular to this for any two non-zero vectors a and b. If these are perpendicular, it means the dot product will be equal to 0. So just you have to write down like this. Dot product with another vector, that is when you multiply these two, you will get the 0 vector. This multiply them. Mod of a square b square, write down the vector sign on it, minus magnitude of a vector, magnitude of b vector, and this is b dot a plus magnitude of b, multiply them. You know, in dot product, position doesn't matter, a dot b is equal to b dot a. Last term is this one. Now you know these are cancelled. What you are getting? Mod of a square vector, that is b square. Again this is b square, both can be written as in a mod sign. I think this mod of b square and mod of a square, both are again cancelled and equal to 0. It means what? Hence proved. Vectors are perpendicular. These are perpendicular vectors. Okay. I think try questions of exercise 10.3 and 10.4. I will send you the solution of 10.3 and 10.4 both. You can match your answers with the solutions. Thank you. Have a nice day.